we're going to go over the class exercises for those of you who weren't able to see, or we'll just go over, if you just wanted a quick refresher of how we went over the hypothesis test, we'll go through what I showed today in class. So if you open up the Excel, we have a bunch of data, in a bunch of different tabs, right? So we'll go over the first example we went over, which is the one sample z-test. Okay, so on the left side here, we have a bunch of volumes from the machine, right? We have quite a bit of volumes from the machine. And what we want to understand for part A of this question is we need to determine if the average liquid volume is significantly different than 600. Okay, this is key right here, significantly different. This is also key, 600 milliliters on average being dispensed by the machine. What the question is giving us is that we have the mean, and in this question, we're also given the standard deviation. So we're given a bunch of stuff. We're also given alpha, which is 0.05. Given the mean, 600, and we're given the standard deviation. If we want to calculate, first of all, quickly want to calculate sample size, we can do that by using the count function, right? Count of all the data in this column, press enter, we have 40 samples. When we have 40 samples, and when we have the standard deviation, which means we can calculate the variance, that means that we can run a z-test, right? So we have the standard deviation, we want to calculate variance. The way to do that is to square or multiply the standard deviation by itself, right? So you go here, standard deviation, you multiply it by itself, and that gives you 10,000 for the variance. Now we want to put in the hypothesis test, right? So for part A, these two words become very important, significantly different. What that means is that we want to run a hypothesis test that tests whether or not the machine is outputting something different from 600 milliliters. So right away we know that the hypothesis test is going to be 600, mu is equal to 600, because that is the average volume. And we want to test if it's significantly different than 600. So it's not 600. And because we are testing it this way, this is a binary kind of test. Either it's 600 or it's not 600. That means we have to essentially look at the two-tailed test value. So the way we want to do this is we have the alpha value here. We go up here to use Excel's function. Before we do that, we want to put in a dummy column here, because the way I do this is we kind of try to fool Excel into essentially running a 2 sample test, but we're running a 1 sample test. So go up to the data tab here, go into data analysis, click here, then we go scroll all the way down to the z-test 2 sample for means, right? And we will adjust it for the 1 sample. So you click OK. When you click OK, this is the dialog box that comes up. For the variable 1 range, we need all the data that we have, right? So all of this stuff. For variable 2 range, click the dummy data. The hypothesized mean difference, or the mean, is the 600 that we're given by the question. The variance of the first variable, or first data set, is we've calculated it at 10,000 because we squared the standard deviation. So put that in there. Variance of the second variable, because it's dummy data, we want to put 0, but we can't put 0. Excel won't allow us to put in 0, so we just put a really, really small number. We check mark labels, and the alpha is 0.05. And let's go down here, we'll click on the output. You can output it into a new worksheet if you like, but like I said, I like to put it into a specific cell area. So let's put it, let's put it here. Doesn't matter. Yeah, let's put it here. Click OK. Now that is the results that we get. Now recall that we went to here, we wanted to look at a two-tailed test because it's either equal to or not equal to. That denotes a two-tailed test. So go here, we look for the p-value. That's a two-tailed p-value. It tells us that it's 0.981. 0.981 is greater than alpha, or 0.05. When p is greater than alpha, we actually fail to reject the null hypothesis, and so the null hypothesis is the one that's valid. And our null hypothesis is that the average is 600. So in conclusion, we don't have the evidence to show that the machine is dispensing volumes different than 600. In fact, it's probably pretty bang on at 600. For part B, what we want to do is we need to determine, now it's a little bit more of a focused question. We need to determine if the average liquid volume is significantly greater than 600. So now is when we are going into the one-tailed test. So our hypothesis is going to be that we're testing whether or not the alternative hypothesis is going to be the fact that we are testing whether the volumes are greater than 600. And so the null hypothesis is that it's either equal to or less than 600. So now, because we are looking at either a greater than or lower than value, we can do a one-tailed test. In much the similar fashion, we can run the same data analysis, but since we've already run it, we can just go back up to this output and look for the P of the one tail. The P for the one tail is 0.490, which is still greater than 0.05, which means in this case, again, p-value is greater than alpha, and we fail to reject the null hypothesis again. That means that this, again, is probably valid, and so we don't have enough evidence to show the machine is dispensing volumes larger than 600. So it's most likely equal to or less than 600. That's the one sample Z test. We can do it again. So let's go over to another one sample Z test. We'll go here. In this case, we have all this data down here. In much the similar fashion, we can do a count to look at how many variables we have here. It's 40. Anything above 30 is going to be good to do a Z test. But what's more important is that, again, we have both the mean and standard deviation given to us. So anytime we have the standard deviation or we have the variance, it's likely that we want to run a Z test. In this case, we want to determine if the average sales by the store is significantly greater than 600. We're looking at one side of the equation here. Is it greater than 600 million? So that denotes a one-tailed Z test. So we do our hypothesis. Alternative hypothesis is that our mu, or mean, is greater than 600, and the null hypothesis is that the mu is less than or equal to 600. We already said that we're going to do a one-tailed test, so anytime you see these symbols greater than or equal to, or greater than, less than, it's likely that you're doing a one-tailed test. Again, the alpha is 0.05, so we have all the information that we need to basically run another Z test. Can't forget to put in some dummy values here to confuse Excel. Go back up here to the data analysis tab, click it, Z test, press OK. So let's put in our values. Are they correct? All the values in here. Variable 2 range is here. Hypothesized mean difference. Hypothesized mean again is 600 because we are given that in the equation, 600. Variance, we didn't need to calculate it because it's kind of the same as the previous example, but if we did need to calculate, it's 100 squared, which is 10,000. We put that here. This is the dummy's variance, which we want to have as low as possible. We add the labels, and we do 0.05 as the alpha. We want to output it. Let's output it. Oh, I have to click here. Okay, let's output it right there. That's fine. Click OK. Now we have the data. We are looking for a one-tail. We run a one-tail test right here. So we want to look at the p-value for the one tail. And we see that is 0.0047, which is less than 0.05, less than alpha, which is right here. So if your p-value calculated is going to be less than alpha, we need to reject the null hypothesis. This is not true. Therefore, we accept, or we have evidence to show that the alternative hypothesis may be true, and we can conclude that Store A does actually, on average, have more than $600 million in sales.